Hey everybody, this is Larry. This is day 18 of the Leetcode Day Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's problem. We have a easy problem. Yes. So I could take a nap after this and before the advent of code. I just went 10 miles today. It's my last run in New York for this year. So I'm honestly a little bit drained and just need to take a nap after eating. But let's take a look at today's problem. Is it easy? So hopefully it is actually easy and we don't make a traditional classic Larry mistake. Okay, today we're at $14.75. Final prices with a special discount in the shop. Okay, so we have prices of I is the price. Okay, you have a special discount. You buy the I item, then you get a receive. Then you will receive a discount equivalent to prices of J, where J is the minimum index such that J is greater than I, and prices of J is what? Okay, I mean there's something, but I have to read it again. If you buy the I item, you this equivalent price of J, where J is the minimum index, such that J is greater than I, and what does that mean? Let's take a look at the example. I still don't know. Okay, so price of 0 is 8. You discount, you go to 4. Why 4? Because J is the minimum index where it is smaller than the price. Okay, so I guess so it is basically the next number that is smaller than it, right? So 4, you pay 2, or you receive a discount that is 2. 6, you pay 2, and 2 you do 3, right? Okay. I mean, this is easy because n is 500, so you could do a 500 500 square solution and n square solution. But this one, I think it's worth practicing to upsolve. There are a couple of ideas here. I always don't. Yeah, I mean, I think there is definitely a linear solution. Honestly, I don't. I mean, some people do advocate in memorizing these things. I never do, so that's why I'm going to be a little bit slow on these. Because I think the thing about these problems is that you have to work out the invariant, and once you have the invariant, you can kind of use it to reuse energy, right? Like reuse the work and calculations that you have done, right? Okay. So, for example, we have 8. You have 4. Okay, so for 8, what do? Okay, we keep going. We push it on, say, a queue or a stack, probably a stack. Then 4, I think the thing to do is maybe to ask, okay, if I'm at a 4, now that it's either that you could process backwards, I suppose. So maybe we can do that as well. Yeah, I mean, maybe that's easier because sometimes, yeah. And processing backwards, what does that mean? So 3, we have no discount. 2 is less than 3, so we don't have to consider 3 anymore because I think that's slightly easier. Because basically any number that is because the idea, what I talk about when I talk about invariant is that when you see a 3 here, right? Okay, let me write it on the ASCII a little bit. You start with 3, let's say we reverse it, and then you have a 2. The thing is that when you have the 2, now we know that numbers to the left, we're working our way to the numbers to the left, and we can have a big number, let's say 100 or whatever. But whatever it is, 3 is never going to be the answer anymore, right? Does that make sense? 3 is never going to be the answer because anything that is bigger than 3 is also bigger than 2. So then 3 will never be the answer. So we could kind of throw away 3, which allow us kind of keep this thing. And then now the same idea is that, okay, let's see the next number 6. Okay, 6 is okay. Because if you have a number bigger than 6, then 6 is your answer. If not, then 2 is your answer, right? But you kind of have to play around with this, right? Because let's say, okay, so then we want to keep 6 because 6 is bigger. But then the next number is 4, is it? Yeah, 4. Well, 4, we go, okay, well, 6 is greater than 4, so 6 is not the answer to 4, obviously, right? But in the same logic that we just did, 6 is bigger than 4. That means for all the numbers to the left, 6 cannot be the answer. So you throw it away. And then we see that this is 2. So that's basically the idea. I know that people call this like mono stack and stuff, right? Excuse me. I had very spicy food earlier, so I'm just like, maybe I need to drink some water and stuff. But in any case, yeah. When I talk about invariant, that's what I mean. And when you have, I don't really think about stuff like mono stack, mono queue, and all these things. I just think about, okay, what is the thing that allows me to keep on, what is the question that allows me to keep asking to get the answer? And that's basically it. Okay. So this is, the way that we did is probably not easy, because the easy would just be n square. But yeah, I'm happy to kind of do it this way. Right, so maybe we have answer is equal to right? And then we have a stack. And then yeah, maybe we start, I always like, so I sometimes do it, but sometimes I don't, not consistently enough, is with a sentinel value. And here we actually want things to be negative infinity, so that this will always terminate, right? So then now we have x is equal to price sub I, and then now while the top of the stack is greater than x, we just pop. And then now we can stack dot append x, so we put on the stack. But also that means that the top of the stack is your discount. So if, I guess we do have to kind of write this anyway. So if the top of the stack is greater than 0, and you get a discount, so then that means the x minus stack of -1, right? Otherwise, you get no discount. I mean, I guess you could write this as like this or something, right? Right. So yeah, and that's pretty much it, really. And then you have to reverse it, right? Because we were going backwards. But that's it, right? And then we'll give it a quick submit, and we are Gucci. I wonder if I did it n square last time. Did I click on some by accident? I mean, I think for Yeezy, especially if it's a contest problem, you definitely want to do it this way because it's just so much faster. But yeah, but this is also not that bad. You just have to kind of work out what you want to figure out. And hopefully kind of my thought process helped you. This is linear time, linear space. Hopefully easy to prove. This is linear time, right? I guess this looks a little bit awkward sometimes, but this is a pop and you can only push one at a time. So that means that this will only happen linear time, and so we are Gucci. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.